Start recording. Start streaming. All right, I think we are up and live. Looks like it. There we go. Cool. Let me tweet this out to the remaining fan base, if you want to call them. All right. Trying to organize my windows so that I can switch between what I need. Does it? We should test Casey's audio. Casey, you want to talk a little bit? You're muted. Can't hear you. Technical difficulties. I can hear you now. Interesting. So, all right, we got a few second delay. We got 4 people on. You can wait a couple minutes and get started. Oh, that's a good point. Let me see if I can add an input source. Hmm. I don't know if I can do that. That would not be good. I wish you could just add Casey to the stream.
Can you hear him now?
Try to talk, Casey.
I'm guessing he can't hear you.
Kevin's also muted, so. Double sound from me. Okay.
So we are using OBS, but do you know a way to add Casey to my current stream? I'm talking to the guy that's chatting us.
Good try.
All right, let's try that. So
you guys can hear Casey and Kevin.
So there's somebody in chat saying that you have to add an audio capture for the Google Hangouts window.
I did do audio input capture, but
oh yeah, I can hear myself on the thing.
So Casey, try talking.
Okay, can you hear me now? I guess I'll keep talking until Kevin says something, maybe.
Yep, you're good to go. You're live, Casey.
Awesome, cool.
Does it sound pretty good? All right. Well, I will try and adjust that as best I can.
But yeah, audio levels are good.
Cool. All right, well, we got some viewers, so I think we can go ahead and get started. All right, well, I don't know who all's online. This is our first time doing this, but thanks for joining. And we have Casey here with us today. Casey will be giving a talk on Git. He gave a similar flash talk about, I think it was back in July, and that was pretty well received. And we asked him to come back again and give another talk. Hopefully a little more in depth this time. And we decided to cancel the in-person meeting today just because of the weather. It was really icy out there, so we wanted everyone to stay safe, and we decided to try and throw this
live stream together last minute. So bear with us as we try and work out some issues. But all right. Well, in case anybody doesn't know, we have a website, our Twitter handle, and our Twitch handle. We also have a YouTube handle. All of our handles are full stack TC, and we also have a GitHub handle as well. On GitHub, you will find our meetup notes on there as well. So all of Casey's notes he will submit to GitHub, and they'll be available after this. And the website will have a link to this recording that we will upload, and if you'd like to review it. So shout out to our sponsors. So Fuse for allowing us the use of the facility. Oh yeah, no problem. Glad you didn't drive in from Walla Walla. That would have been dangerous. So thanks for joining online. So thank you to Fuse for providing their facility for us to use on a regular basis. I know we're not there right now, but still shout out to them. Wheelhouse provides us with drinks for our meetups. And for Wildlands for helping sponsor this on a regular basis and normally provide our beverages and our food for us, as well as a little thank you for the speakers. So thank you guys. Wildlands is hiring, so if you go out to their website, wild.land/careers, you can check that out and look at the cool opportunities they have to offer. So one more plug before we move on. Kevin runs TC Game Devs. It's another, it's kind of like a meetup, I guess. Kevin can elaborate a little bit more, but if you have interest in checking them out, please do so. They have a Discord out there. You can go out there and go to this address, and you will find some more information. Kevin, did you want to add anything to that?
Yeah, so this is kind of a newer meetup, which is kind of the idea of an unhackathon or kind of an anti-hackathon. So as opposed to prototyping something quickly over 24 or 48 hours, it's kind of a book club for whatever game dev project we have going on. So we meet 4 hours monthly, and it's really supposed to be a community that helps people kind of get together and encourages each other to work on projects and kind of see projects through to the end. So yeah, come join us if you're around. We do rotating days of the month, so we will do first Friday, first Saturday, or first Sunday, usually from 6 to 10 at Fuse. So yeah.
Cool, great. All right, and I normally throw in a shameless quote. So this time I'm going to quote Thomas Huxley. I don't know who that is, but he said, try to learn something about everything and everything about something. So the motto of our meetup is to basically try and encourage each other to learn and to teach others what you know and build a good community around yourself. The Discord link has expired. I will leave that one up to Kevin. So he can hopefully shoot you a valid link in the chat. Thanks for checking that. So, all right. Next month, Tabon will be coming down to speak on API and testing. I believe he's going to be using Node.js to do this. He was scheduled to present in February, but he lives in Seattle and the weather got terrible, so we postponed him to April. So, weather permitting, he will be out here. And if you would like to give a talk, May 1st is open. If you have anything you'd like to present, email myself or Kevin, or go on our website, and you are able to submit a talk on the website. We'll put you in the queue. For today, though, I'm going to kick it off to Casey, who is going to talk to us about Git. This is a lot quicker over Skype. Let me get to my Hangouts window.
All right, let me share my screen.
That's the wrong one. Not me.
All right, looks like it's up there. Cool, okay. Can you guys hear me?
I can hear you.
Awesome, all right, well, good enough. Let's get started. thank you for coming to the talk. Really excited to be invited back. So this talk is called Intro to Git. Next slide. So a little bit of background about myself first. My name is Neubauer. I'm a software engineer at Pacific Northwest National Laboratory. I'm a back-end web developer, and my preferred language is Python. I use Git on a daily basis, and I really enjoy working with it. And it's kind of been my secondary mission to kind of convince some of the scientists and engineers that I work with to adopt Git if possible. Mostly because I get tired of trading files back and forth in email, and Git is certainly a better way to, at least in my opinion, a better way to manage lots of files like that, particularly source code. All right, so what is Git? Git is a distributed revision control system, and it's DRVs or RCS uses to track changes in any set of files or revert to previous versions of those files. So again, this is mostly used for source code, but when we do that, we can track basically the little deltas, and when we make a change to a file and record that delta so that we can jump back to it later if we want to, or for coding and stuff, if you go down the wrong path, make a bunch of mistakes, and want just kind of a clean version of your code that you knew was working, this would be a good way to do that. So again, uses and motivation. It's primarily used by software developers, this tool, to distribute and merge their work across not necessarily even the same physical locations too, and manage their sets of files across versions. It can be used for pretty much any kind of file. However, again, it's mostly used for text files. When it's used for binary files, it can be used for binary files. However, it doesn't mean you can't really see the difference between one set and the other. Just these two binary files are different. All right, so installing Git, I have a couple of links here if you want to install Git and follow along. There's a Git client, a GUI client, at SourceTree, and I prefer using the GUI client for more complicated things, and it's a really nice graphical way to kind of see what's going on. And then there's a command line version you can get at gitscm.com. And of course, if you're on Mac or Linux, you can also use your preferred package manager to install Git. Either Yum or apt-get. I'm not sure what Mac uses. Another thing I actually forgot to put in here is when you're installing Git from, or when you're using an IDE, such as Visual Studio, Eclipse, NetBeans, and so on, most modern IDEs have source control as part of the IDE, so you can also use it from your preferred tool there to integrate with Git, and that's actually really helpful if you have a large, complicated project. It's not so useful for like small one-off projects, I find, but if you're doing like a large monolithic software project, it really can be useful to use it as part of your, like right there in your development environment. All right, so next let's move on to concepts and basic usage. There's a couple concepts I want to cover real quick, just to kind of make sure everybody understands them. This talk is geared towards newer users to Git. So if you're already experienced using Git, this will mostly be a review, but hopefully there's one or two useful bits in this talk. So a couple concepts first. A Git repository is any directory that has a .git directory. It's a little hidden directory that has all the special files Git uses to perform its tasks. And this can be, I might refer to a local repo or an external repo. A local repo is a repository that's on the same machine, the same physical box. And an external repo is just one that's not on the same physical box. So it's on a server someplace external. It can be in the web, it can be in the cloud, it can be on another hard drive, just not on the same machine right now. And then the other important thing is commits. Each commit is basically a set of changes to one or more files. And when we make a commit, we basically back it up. We save it for later, and we can then jump back to that point at any given point in time. When we do that, it's important to, I might say, just different kinds of commits. That's just what a Git commit is. All right, so setup and basic usage. So let's cover setting up a basic Git repository. Let me switch windows here. Stop screen share and jump to my other window. Start screen share. There we go. Okay, cool. Make sure it's still there. Awesome. So first thing we want to do is we want to make a new folder. So make dir. And then to create a new Git repository, we go into the directory that we want to make into a new Git repository. And we just type git. It'll say something like initialize empty Git repository. And if we do an ls-a, we'll see that it has a .git folder now, or a .git directory. That's the special folder that Git uses to store all of its objects and hooks and things like that. I'm not going to talk about like the stuff in it, and it's kind of out of the scope of this talk, but if you ever want to dig around in there, you can see all the cool stuff that Git uses to, it's mostly just a bunch of binary objects as far as I understand, but you can see what Git uses in there. So now we need to add some files. So let me copy a couple files in there. Please bear with me. It's going to take a second to jump out of my folder and into another folder. What do I have here? It should be there now. Okay, so I added a text file. And it's just like that. It's just basically a copy of my bio that I submitted to Full Stack. So first things first, we got to see what's going on. So the way we do that is with a command called get status. And get status is kind of the bread and butter of using Git. It shows a bunch of information about what's going on with the repository right now. So we're on branch master, and I'll get into branches in kind of the second half of this talk. We don't have any commits that we've done yet, and we've got one untracked file, which is this bio that I've made. So to make sure I'm not getting ahead of myself. Yeah, okay. So to add the file, we're going to do a git add. And when we add files to Git like this basically marks these files as staged for a commit. So we can't do a commit until we've marked the files as yes, we want to keep these files, or no, we don't want to keep these files. So when we say git add and add a file or a set of files, we can do more than one, or we can put a directory on the command line as well. That will mark it as added. So if we do a git status again, this change is ready to be committed, and it's got one new file, right? So if we were to add another file, that file would show up as not added yet. Copy that, paste it there, and then do an ls dash. Added another notes, and now we have one new file and one file that hasn't been committed yet. Double check here. All right, so if we wanted to not have that file staged for commit, if we want to unstage it, if you will, we would do a git reset. The file has been removed from the list of staged files to be committed. So let's go ahead and add that again. And git status to check it, and there it is again. So now we're ready to do a commit, and that makes, we're going to make a new commit. We're going to mark it as ready to be something we want to keep in the repository. We're going to do a git commit. We're going to specify a message with -m and add bio file. The commit message is optional, but it's helpful because when we go back and look at it later, it's kind of a description of what we did, what the work that was done, the changes that we made to the file or set of files. And so it's extremely important to have a commit message. Otherwise, we might not know what we did. We'd have to go look through and read the file by hand, and that would take a lot more time. All right, so we've got one file changed, 3 insertions it looks like, and now if we do a git status now, Now we don't have that file. That file doesn't show up anymore. So we can check previous commits by doing git log, and that will show us the log messages for all of our previous commits. So we can see that I made a commit here just a second ago, and I added the bio file. That's the commit message before. If we were to, let's see, again, I don't want to get ahead of myself. Let's make some changes to the file. So now we want to make a couple changes to the file. We're going to open it up in a text editor, and I'm going to just keep my command window open. I'm just going to take out a line in the middle here. And save it. Hit status. So now we've got a modification to the file that we've been tracking. One thing that's important to note is that if I were to have changed this intro to Git notes down here, it wouldn't have kept track of that change because it's not being tracked by Git currently. Only files that are being tracked by Git currently are going to be noticed by Git, if you will. So we can see what's been changed specifically by typing a git diff and then giving it the file. Right. This will specify, oh, it's all in one line. Oh, dry. Well, I took out my name and put I instead of in the third person for the first line. That was the change I made. But it'll do that on a line-by-line basis. Let me break that out into a different line to give you a better idea of what's going on here. Well, that'll show up in the status as well. We'll do another diff on the file. And all I really did here was add a bunch of new lines to space it out better. And you can kind of see that here with all the little pluses. So the minus is what was removed, and then the pluses are what was added. And in this case, I took out one giant line and made it a bunch of smaller lines to modify later. So let's go ahead and add
Hey, Casey. Hey, Casey.
And commit that.
Casey, can you hear me?
Empty again, and let's do another git log. And now it prints out all the log messages, so I have just 2 log messages now. If I had hundreds of log messages, we could specify only the last so many log messages by giving it -n. If I want only the last 1 log message, it would only show the most recent log message. So if I had, again, hundreds of commits, we would want to do something like that. Otherwise, it would print out all of them. We have to scroll through it. All right, moving on. So this Git repository, I want to talk about kind of pushing to other repositories. This Git repository is currently isolated from all other repositories because I created it right here in the command line. It's not attached to anything anywhere else. So that means that if I were to go up a level or 2 and then remove the folder, RM, we couldn't restore it. However, any files in here, we could restore. If I were to say, move this file, bio, because it's being tracked in Git, now it's gone. It noticed that it was deleted. So I could commit that change if I wanted to, or if I didn't want that, I could check it out again. And now it's back again. So that can kind of safeguard against accidental deletion. That's something that's actually really useful to me because I've lots of times accidentally deleted something and I just, oops, I want to get that back real quick. And that's easy to do with Git. And again, a lot of this stuff you can specify instead of like just one file, you can specify more than one file, or in this case, a directory, and it'll work just the same. No, but what I was going to talk about next is the next thing I was saying, how this repository is kind of isolated from the rest of the world because it's not attached to anything. It doesn't have any remote repositories, kind of the word I was using before in the slideshow. So we can check what remote repositories we have available to connect to this Git repository by typing git remote. Right now we don't have any because I didn't set any up. if we have dash dash verbose, again, there's nothing there. So we want to add a remote repository, or we can add a remote repository by typing get remote add and then specifying a path to link it to. Since this is just kind of its own repository, I'm not going to do that right now because I don't have an internet source to link it to. But we could. And actually, kind of the other side of that is a command called get clone, which I'll get to in a little bit here. How am I doing on time? I'll get plenty of time. Okay. Let me check and see. Okay.
If you wanted to get fancy, you could use a local.
All right, so next we want to link up to another remote repository. So I'm going to create a quote remote repository in the same machine as me. Normally that's kind of frowned on, but I kind of want to keep it all in the same system. I don't want to go through the rigmarole of hitting up another external source right now. So in 1 sec while I do that. I should have one under the C drive now. So that get remote add C / webapp.get. Did I just mess it up? Oh, I forgot to add the name. Whoops. Oh, so most get applications by default call the first remote origin. So we're going to call this one origin, and there's the path to it. Now if we type get remote -- verbose, now we have a fetch and push to a new remote called origin, and there's the path to it. Again, most of the time this would be an internet address, so like http:// www. some website. But in this case, because it's kind of a small little example, we're just going to use a local repo. So the next thing we would want to do is, if we're going to commit or share our work out to the rest of the world, or in this case, my little simple repo, we want to do what's called a get push. Let me type status again. Okay, so we want to do a get push to the remote repository, and what that does is basically when I do a commit, that saves it on my local machine, but the rest of the world doesn't get it until I type get push. So if I'm not ready, or I want to like save a whole bundle of commits together, we would wait until we're ready, and then we type get push, and then all commits that we've done will be pushed out in that in the current branch, which is master right now, would be pushed out to the remote that we specified. So in this case, I'm going to specify origin up here, and we're going to type get push and master. Well, rejected branch is currently checked out. Uh-oh, looks like I messed up there somewhere. What did I do? I might have set up the remote wrong.
I think your remote repo is on a bare repo. That's the problem.
Oh, interesting. That's not good. That's even worse. So what I did was I deleted the Git directory in the wrong spot, and it looks like the remote no longer exists. Oh, I know what I did wrong. Okay. let me try it one more time. Oh, really? Not again? Oh my goodness. I get it. Oh. Okay, there we go. My apologies for that. I completely messed up setting up the remote repository, so that was on me. Ordinarily, you would just have to link it to the appropriate spot with git remote add. But what I did is I messed up setting up the remote repository, so please ignore all that. That's my fault. At any rate, now we can do git status, and let's make a new commit. Right. Status. So I modified the bio again, and I took out a line. So we're going to commit that change. Line. Oh, whoops, I forgot to add it. Add. So I have to stage it before I can commit it. So get add bio. Move the line. Now if I run get status, it should say by one. Anyway, now we can push it out to the remote repository again without any problems. Okay, and it got pushed out again. I think I should move on to branches before I keep making mistakes with my silly little example. Okay, let me swap out to the slideshow real quick. That's not good. The button's not working. Hey, Michael, you there?
I'm here. I'm talking. I'm assuming everyone else can hear me.
Hey, Michael, can you hear me?
I can hear you.
I think he's in the messages.
Oh, he's in the messages?
Yeah.
Thanks. So I can't seem to get the...
All right, man. Can you hear me now?
Yeah, I can hear you.
All right, cool. Sorry about that. Yeah, you can rejoin?
Yeah, I'm just going to exit and rejoin. That seemed to fix it the last time right before we started.
All right, sounds good. All right, let's give the audio a test here.
All right, can you hear me again?
I can hear you. Can live streamers here?
Yeah, it sounds good on the live stream.
Great.
Okay, I'm sharing my screen again. All right, so the next thing I wanted to talk about was branching with Git. So branching is kind of where things start to, when I first learned Git, that's where things started to break down for me, because I'd already learned like a lot of the kind of the basic concepts made sense, like, you know, storing changes, tracking changes, restoring to changes. That all made a lot of sense. But when I got into branching, that's when I really started to have trouble with Git. So I wanted to spend some time talking about what branches are, how they work, and just kind of a real basic quick overview of what branches do. Um, so the motivation for branches is Git commits are organized into branches. And actually, you might have seen when I was doing the Git status a second ago, we're on branch master. So Git actually has one branch by default, and it's the master branch. Branches allow for more detailed project organization, and so you can kind of break out your commits across multiple different branches. And in my experience, it's absolutely necessary for most teams, because what happens with most people is we end up, if you have a medium-sized team or larger, a lot of the work that people do might kind of run into the work that other people do. So, for example, I might be modifying the same file as somebody else, and if we're both going back and forth in commits, that would kind of defeat the whole purpose of using version control if only one of us can work on the file at a time. So by using branches, that lets us kind of get around that limitation. So two people can work on the same file at the same time without and save the results across time without having to wait their turn, so to speak. All right. So what is a branch? Technically speaking, a branch is just a special pointer to a specific commit in Git. Git actually kind of uses branches to refer to like the master branch, like we said, but other branches are the same thing too. It's basically just a special little spot that it can get back to in a long, long list of commits. The default branch name in Git is master, and I think it might be kind of the same with, I don't remember Subversion very much, but it should be something similar with SDN. Anyway, a branch, like I said, is a way to continue to work on a feature while leaving your working code intact. So what, again, what a lot of professional teams will do is they will make a new branch for new features while they leave the master branch is sort of like the working release branch. So that's where all the working code stays, and nothing goes into master until it's been tested and it's working and it's all good. There's no problems with it. Some teams further break that up into having multiple sub branch trees. So like you could have a development branch, you could have a feature branch, you could have a hotfix branch. That's getting kind of too deep in my opinion, but again, maybe it's necessary for some teams depending on how complicated their project is. Oops, that's too far. So let's go back to the terminal real quick and I'll show how to set up a branch. Stop sharing and then share the other screen. Where does it show? Two command windows, that's interesting. I have two windows. There it is. Okay. Cool. So the way we look at Git branches on the terminal is with Git branch. It'll show us all of our Git branches, and right now we just have the one branch, and the little star indicates the current branch. So if we do Git branch -a, it'll show us all the branches. We have this extra one, remotes origin master, and that's something I actually forgot to mention. What that is that's basically the remotes list of branches. So I might have my own set of branches that I work on, and someone else might have a completely different set of branches that they work on, and we only commit to, say, the master branch or the development branch. We kind of keep our own personal branches the same. That also lets you kind of work on your own side stuff in a personal branch without colliding again with other people. So since each Git repository is a completely separate sandboxed thing on its own, it can make commits without having to be connected to the rest of the internet. You could potentially have all kinds of branches that aren't anything to do with what everybody else's branches are doing, which is kind of cool. But to make a new branch, we would type git branch and then the branch name. So let's call it first feature. And if we type git branch again, it'll show us 2 branches. And again, the star is still pointing to master because I haven't switched to the branch yet. So if I type to switch branches, we would type get checkout and then the branch name. So first here. And if I type get branch again, and the little pointer is switched to first feature. There is a shortcut to doing that. I believe it is to making a new branch and then immediately checking it out. I believe the shortcut is get checkout -B and then give it a new branch name. So let's call it second. And then yeah, so it says we switch new branch second feature. And then so there's all the branches. Check my notes real quick. I believe if I remember right, you can delete branches by saying hit branch -D and the branch name. Okay, delete it. So get branch -D to delete. So we're on this branch here. Let's do something, and then let's check it back into the master branch. So I'm going to go ahead again and just open my little text editor off to the side and paste some new text into bio file. Save, and if we do a get status, now we've modified the bio file again. So get diff. Oh, I've added some new lines just from my notes section. And so what we're going to do is we're going to do a commit. So we're going to get add bio, then get commit, and added new feature, something like that, some descriptive message. Get status. Oh, one thing I also forgot to mention here in the get status. If you look at get status, before it would say on branch master, but now we're on branch second feature. So that'll tell us what our current branch is, which is extremely important if you're working on lots of stuff and you want to make sure where you're at before you make a commit. So what I would do when I'm doing like stuff for like my projects, when I run a get status, I make sure I'm on the proper branch before I commit to it. Don't want to accidentally commit something to the wrong branch and get like the wrong code put in the wrong place. So now if we were to say go to master branch, back to the master branch, get status, they show up here. I might, after the end of this section, I might switch to using source tree to kind of give like the other interpretation, to kind of walk through all these steps with source tree in a second to show how it looks with a GUI. This is one of the reasons I actually really prefer using a GUI in some cases, is because it makes branching a lot more easy to understand and easy to see. So let me let's see, check my notes again real quick. All right, yeah. So let's merge the branch in. Let me turn in the right place. Oh no, I have actually a couple of slides for this. Let me swap to that to kind of explain it real quick to talk through it. Stop screen sharing and what is it? Display share screen and back to the slideshow. If it shows up, that's interesting.
You broke it.
I broke it. Be right back.
Lucky for us, Hangouts will be discontinued soon.
You just gotta put memes on the screen.
Exactly.
Looks like I have 2 screen shares and then it crashes each time. right, can you hear me?
See if the audience can hear you.
Yeah, sounds good.
Awesome. Okay, moving on. So merging. So branching and merging is the stuff. So after we've made a branch, we eventually want to pull that stuff back into our existing code base. So once we branch out, usually we want to pull that change back into our primary code base at some point in the future. Sometimes not. Sometimes we want to just keep it separate. But most of the time, we want to eventually pull our changes back into the main code base. So that's what a merge is. A merge is when commits are pulled from one branch into another. And after a successful merge, both branches are pointing to the exact same commit. So I'll show this in more detail in source tree, but what that means is when we make a branch and then we make several commits, that branch is currently ahead of another branch. So it's pointing to some commits farther in the future than the branch that it came from. And a merge might be unsuccessful when we have a merge conflict, which I'm going to try and show a real quick example of that later. I know I might be running out of time here, so we'll do that in a minute. So we'll do that. And here's my second screen share before it goes bad. Share screen. Back to the command prompt. All right, so we should be on, I don't know if I'm going to write the master branch. Status, yep, on branch master. So now we want to merge. We want to merge that second, actually, make sure I can spell it right. Second feature, that's right. We want to merge, get merge, and then we're going to specify the branch to merge into. So this means when I type second feature, that commit that I made a minute ago to the second feature branch, that's going to get pulled into the main branch, so the main branch, or the master branch, so that both branches will be pointing to that same commit. And actually, before I do that, the commit in question is going to be the most recent one, which is get log -1 when I removed a line. So, merge second feature. And now if we type in a new feature, and that's really kind of the best example that I have right now. The unfortunately, it doesn't really show us much in the way of graphical. So I'll show the example of a merge conflict and how to fix it real quick, and then technology permitting, we'll switch to source tree and I'll show all this again, and hopefully it's a lot more graphically easy to see, especially with the branching. So a merge conflict is when we have two commits that disagree. When I mean disagree, I mean that let's say I work on a file, somebody else worked on the same file, and we both changed the same line in the same place, and we made different changes, and so our changes don't match up. Normally, Git is able to kind of merge things together pretty easily. So like the change that I just made, there was no real problems because I hadn't made any commits to master branch. However, if I had changed the master branch around the same line and I'd done something else, I'd added some new lines in that same place, then a merge conflict would have happened. And I'm trying to actually set one up real quick while I'm talking here. And when that happens, Git can't resolve it without knowing for sure which version we might want. So let's say I make a change in two places or in two different commits to the same place in their same set of lines in the file. Git on its own won't be able to tell which one we want to keep. So we have to specify to Git, we have to tell Git which one we want to keep of the changes. So I'm going to make a change to bio again. Saved, maybe it didn't save. Forgot to save it, whoops.
Classic.
Okay, so I took out this line and I modified, technically I modified this line, but it took out that and added that, so I added the other two operating systems. So we're going to make this commit, right? Git add systems. So that was on the master branch, right? Now we're going to go back to the previous branch. So get here. And I'm going to make a change in the same place on that same file, but it's going to be a different change. Okay, so that's the same line, but I put the order of the operating systems a little bit differently, right? So let me do the bio again. Order. So let's go back to master. Oh, yeah, master branch. And let's try to merge it. All right, so we have a conflict now. Merge conflict in bio.text. Automatic merge failed, so it couldn't merge it automatically because the same line was changed in the same place, but in two different commits. And this is different than modifying a file once, then checking it out and modifying it one more time. In this case, the file was modified 2 times in different branches. So we have to fix the conflicts and then commit the result. So if we do a git status on this, we'll say unmerged paths bio.text. I wonder if I can, if I have bin installed this. Oh, I do. Wow, okay, cool. I forgot that I had this. All right, so what we have here is this is the source of the problem right here. So Git will show 2 different versions of the same set of lines, so the lines that conflict. The one on the left, well, the leftward pointing arrows on the top, I should say. There we go, on line 14, between line 14 and 16. This is the one in the current branch. And in the line from 17, between 17 and 19, this is the one that we're trying to merge in the second feature, right? So basically we can edit this with a text editor, which I'm about to do right now. So, and we choose which one we want to keep. So let's keep this top one. So we're going to delete this. And that. And then these special files here. We'll save that and exit out. So they're still modified, and we use git add to mark them as resolved. So that's how Git knows that we've marked the files as accepted. So that means that somebody's physically looked at it and modified it and hopefully removed those angle brackets and equal signs, because that's really going to mess up your source code if it's actual like running production code. Do git add. Oh. Should say all conflict. Yeah, there it is. All conflicts are fixed, but we're still merging. So we mark them as resolved, but we're not done yet. We have to do one more thing. When we have a conflict like that, we need to merge the changes back in. So once we've marked all of them as resolved, we want to merge that back into it. So it's going to create a separate commit, like a merge commit. So it's a commit that's just specifically for making the changes in that conflict and resolving them. So let's do a git commit. Resolved status, and now the conflict goes away. And if we do a git log, it's like the last 4 or 5 commits or so. So add the operating systems, and then add them in a different order, and then we resolve the conflict up here. So that kind of shows us the history of how we fixed it. Okay, so now technology permitting, I'm going to switch to SourceTree and kind of walk through the process of creating a repository and going through some of the same steps here, and hopefully like a better, more graphical example of branching and merging. I wanted to show it on the command line because it's important to understand how the concept works, but in practice, I almost always use a graphical client for merging specifically. I have a hard time visualizing the branches in my head without like a visual aid. I do prefer Git for like the command line for like regular just Git operations, but whenever I have to deal with a merge or a merge conflict, I want like some sort of visual editor. So let me stop sharing my screen and probably crash out again, but let's see if it'll share screen. Probably not, no. So I'll be right back one last time, hopefully.
Oh, man. All right.
Kevin, Michael, Casey.
Hey, I'm back. All right, let's share the screen. Let us. Here's the buttons. Oh, there it is. Couldn't find it in the list. I have too many windows open. Okay. Looks like it's going through. At least it's showing up on my little miniature Hangouts window. All right, so this is source tree. There's plenty of GUI clients. This is the one I like to use. It's by a company called Atlassian. I should put a link to that in my slides. I don't think I have a slide for a link to it, but I will include that in the notes before I turn them into Michael at the end of this. But yeah, this is, we create a new repository. So we just basically provide a path to the repo that we want to create and give it a name. And I think it has support for Mercurial, so it does more than just Git too. But I'm going to create that. Sure, and we'll create a repository. All right. There's a bunch of windows here. This is, well, there's nothing here, so it's pretty much blank. I wonder if I should, yeah, let me add a new repository. That might be a more better test of it. Let's add a path down to the existing repository. Select that, and then add. So this basically imports an existing repository. So what we have here, and let's go to log history. So these are all the commits that I just did a few minutes ago. So the initial added the bio file. It shows the entire amount of changes. So like the entire, which was the entire file in this case. If it's a really large file, it might truncate it, but that's usually not a problem for smaller files. And here's the change that I made after that, right? So we took out a line and added a bunch more. I broke it down into multiple lines, removed a line. So we can see all the commits we made. And one thing I forgot to mention actually is when Git refers to a commit, it usually refers to a commit hash, as you can see kind of on the far right here in the list. This is like the first little bit. I think it's a SHA hash. It's a lot longer than that, but the first 6 or so characters uniquely identify that commit. So you can specify a commit on the command line as well to refer to it with this commit right here, this commit hash. I forgot to talk about that. So here is what I wanted to kind of show you. This is where we branched out. So we added a new branch and we modified it. And you can see there were 2 commits here, and each little node at the same time was modified. And then right here is when we merged them back into one another. We resolved the conflict. And that for me is actually worth its weight right there, because this is really really easy to see with like a small example, but when there's like 5 or 6 branches going in tandem at the same time, it's really difficult to visualize any of that without a graphical client. Another nice thing actually that I forgot to mention as well is the log messages. It's really easy to kind of click through and see what the last, so many commits history looks like. And if there were more, they would have a scrollable window. You can see with the command line, but it's a lot faster to kind of click through it like this. And then moving on to the next window. So we have file status. So this is all the files that we have unstaged. It's only going to show us files that have been unstaged. And this is the staging area up here. So if I were to say, let me go modify the bio file one more time. Save. Is it saved? There we go. Pops up there. So now I've reordered the operating systems again, right? So it'll show up here, and we can see all the changes that have been made to the file in line. And when we want to stage it, when we want to add it, this is the equivalent up here, the stage hunk. That's kind of like saying git add. And up here, it's been added to the staging area. If they click unstage or unstage selected, it'll remove it, like a git reset, the command that I went over a bit ago. And now it's back here in the ready to be staged area. Well, we can also discard it. So if we don't want to keep this change, we can discard it, and it'll basically revert the file to its original state. So if I click discard, it's going to go away, and now it's gone because the file has been reverted to its original unmodified state, which is handy. I'm going to go back in the text editor and re-add it again real quick. Save. So let's stage it. Oh, another thing, you can also click through line by line, and if there's like tons of different differences, we can click through line by line and say stage it, unstage this specific line or this set of lines, which is very handy. So we can make a commit with a little button up at the top here. This is kind of like saying git commit again. And we'll click commit. And we click commit. Yeah, it's not working. Oh well. Anyway, it would pop up a window if it was working and show kind of like, again, a place to put the commit message and click yes or no. Another thing to mention is on the far side here, we have a list of all the branches that we've created. So we can click over here and view the branch. We can also check out the branch. So we're on the master branch because it's highlighted, it's bolded. Just double click it, we can switch to it. And it'll ask you, sure you want to change it, and say, okay. Oh, whoops, it would have been overwritten. Forgot to mention, so these changes would be overwritten by the content in the other branch. So in order to change branches, we have to unstage this. Commit or change. Well, I don't really care about those changes, so let's revert them and discard. And now we successfully switch branches. And you can see here when I click to the other tab here, it defaults to the second feature branch because that's the most recent commit we've made with this branch. If I go back to master, it'll pop up here to the master commit up here. We'll click OK, and now we're popped up one level there. I think I'm almost out of time, so I added like a slide for questions and answers, and also like talking about miscellaneous Git topics. Is there any questions from, I guess, the people on the stream?
You're actually doing really good on time. There's no particular rush.
Cool. Okay. I did want to show like a more graphical example of branching and merging, so I do want to be respectful of time, but since I've got time, let's do that. Let's make a new branch, git branch. We'll say, call it what?
If there are any questions, people can just go ahead and message them. I'll shoot them to Casey.
Oh, perfect. Okay. So we'll give a new branch name, and we'll check it out. Click Create Branch. And over here, we've checked out yet another feature branch. So this is, again, just like the branches before, but it makes branching relatively easy, so you can kind of just switch between them pretty rapidly. Let me modify something in this branch as well. Save that. Back to file status. Stage selected. It's still not working.
We gotta try putting the message in the bottom.
Oh, derp. Thanks. It's been a while since I've used source tree, if you couldn't tell.
Yeah. On the spot. Always happens.
Yeah. Okay. Okay, there's the commit button. Just a little commit, and it was completed successfully. And close. And now if we go back to the log history, we should have, yes, yet another feature branch. So the reason this one doesn't pop off to the side right here is because we don't have any new changes in other branches. Right now, there's nothing that would cause a merge conflict or really anything to deviate. We can pretty much update all the branches there without different sets of code being a problem. So let's go back to second feature and make another change so that it diverges again. Check out the branch, go to text editor. Status, stage it, and commit it. All right, so now if we go to the log history, we should have two separate, there it goes. So this feature is most recent. So it did kind of switch the order here because the second feature is the most recent. It always shows the most recent one at the top. But you can kind of see how the branches are starting to diverge and get more complicated now, or yeah, diverge. So let's merge across branches, so not into the master branch. Let's merge from one of these into the other branch. So from second to yet another feature. Check out that branch. And now we're going to merge. So we're going to click merge. And we're going to pick a commit to merge into our current branches, which is what the message up here says. And we're going to pick this feature branch, and this is the most recent commit in the second feature branch. There's a bunch of options down here. Kind of want to talk about real quick. This one we always want to do commit merge immediately if we don't have any conflicts. Sometimes you might want to create a new commit. You can do that if you want to. For people who like lots of log messages, you include the message from commits being merged into the merge commit. I don't usually do that one because I usually have a lot of commit messages and I don't want to clutter the commit message up. But anyway, let's click OK. And close. Cool, and now we merge that branch into that branch. Both of these, though, are separate from the master branch, which is way back here now, you can see. I'm trying to think of other miscellaneous features. Oh, yeah, so one thing that I remember that I haven't talked about yet is get pull. This has been kind of not a problem because we haven't been doing much that's connected to the outside world, but in real life situations, you almost always want to do a get pull before you do a get commit, and certainly before you do a get push. This basically pulls in all recent changes that have been made from other people, because this way it avoids running over other people's changes at work or recommitting the same thing again and again. So we will want to do a get pull, and it'll give us a list of remotes to pull. We just have the one, and then or we can change to a different branch. We just have the master branch though. So select master branch. It's not going to find anything, I hope, because there's not connected to anything else. I really hope it doesn't find anything. If it found something, that would mean someone else has been on my machine and has been doing commits, which would be really, really extraordinary. But anyway, if there were other commits, though, it would pull them down from the remote repository. And this is always important to do before we do commits, or certainly pushes to other people's repositories. And then if we want to see what the commits would look like, but not actually commit them and potentially get into a merge conflict, we can do what's called a get fetch. This retrieves all of the commit information, but it doesn't actually merge it in with our repository yet. So actually, a get pull is a combination of a fetch and a merge. In that sense, it's like merging these two commands together. So it gets all the information with the fetch, and then it merges it in, and that's what pull does. It's kind of this shorthand for pulling things down faster. Let me check my notes again real quick. So there are a few other like miscellaneous things we can talk about real quick. I'm not going to go into too much detail because I wanted to talk just kind of like how to use the tool, but these are ways to make the tool better, or you can more feature rich, if you will. One of them is called README. So there's a little file we can put in our repository called readme.md, and that is just a little text file, a markdown. That does is that lets us file status, new file, and it's blank. That lets us put things like installation instructions, how to use our code, things like that nature. That lets us put it in a little simple file, and it's used by a lot of really big services like GitHub to basically kind of provide like a little tutorial or introduction to our repository, to our source code, to whatever our files are, how to do, how to use. It's pretty straightforward. I've included in one of the slides actually a link to a little cheat sheet that I found by Googling around real quick. It uses things like hashtags for headers, dashes, and stars for bullet lists, things of that nature.
Actually, if you want, you can go to, this might be a good segue, you can go to our GitHub page, github.com/fullstacktc.
Oh, cool. Yeah. Okay.
You can show an example of a README file and what happens out there.
Perfect. Yeah. github.com/fullstacktc.
Yep.
Swap my screen around again.
So you're allowed one more screen share right before you got to rejoin?
I hope so. Share screen. Full stack TC, there it is. And I actually did have a slide on GitHub too, so this is perfect. So this is GitHub. GitHub is pretty much the biggest hosted provider of Git that I know of, at least right now. It's got like the most market share from what I remember in my research. And then you say right here, over 31 million developers. So if you're working with an open source project, odds are pretty good it's in GitHub somewhere. There's other services that have lots of projects as well, but GitHub is kind of the main one right now. And this is the full stack TC GitHub page. If we scroll down, we've got a couple of repositories to choose from. Are you thinking full stack TC?
You can go to meetup notes. Might be easier.
All right.
There's more README files in there.
Okay, cool. So here's the README. Basically, it pulls all the information out of the markdown file and it spits it and formats it nicely. So a service like GitHub knows how to format it, kind of like a browser knows how to format HTML files. It's a way of marking it up and saying this is how we present the content for people to see. So if we click on the readme.md file, we can see what the content of that looks like. Click raw, show us the raw file. That's kind of ugly. That's okay. This is a markdown file though. So the hashtag is the bold or the heading, and then this is how we make a link. And then look at the rest is just text. That's okay though. Click back real quick. But yeah, so external sources like GitHub know how to read that file and format it nicely to make it look like a nice README. And then up here, this would be, go back one level real quick. So this is a Git repository in GitHub, so it has a bunch of folders and files, and this is where we would track it. It shows us the last commit, it shows us the latest commit, and that's the commit hash. So if we go to, there's a tab to pull down for branches and tabs, just the master branch right now. But it shows us we have this many commits, we can click on that, and we can see commits that have been done, and who did them, and we can see the changes that they made. Go back. And we can also see branches. I guess there's only one branch, but if there was more than one branch, we could see what those branches were. We could click on them. We could go to them.
The website one, repo has multiple branches.
Oh, cool. Let's go to that one. All right. Two branches. So we've got master and develop. We click on the development branch. And I guess it just switches the little tab drop down. You can kind of see how we navigate around through this. And then one thing I forgot to talk about was the clone button. So when I first set up my Git repository, I used git init to make a new repository from scratch. A lot of the times we're not going to do that. We're going to clone an existing repository. So we're going to pull down a complete copy of the entire repository. And we would do that with the clone command. And the terminal would be git clone and then a URL. In GitHub, basically it gives us this URL. We would copy this and we paste it into source tree, or we paste it into our terminal, and we'd run the command, and it would pull down a complete copy of whatever repository we're working with into our computer. PC. Next, so GitHub. GitHub is at least with the people that I've worked with, the scientists and stuff, they don't normally work with Git a lot on a daily basis. They kind of confuse Git with GitHub. It's not quite the same thing. GitHub is a service, a web service that runs Git and provides hosting services for Git. Git itself is actually just a set of programs that we run on our own machine or on someone else's machine. But GitHub has a lot of nice features like letting us log in. Git by itself doesn't provide any kind of authentication. It's just a file set structure. So it doesn't have any concept of logging in or logging out. But GitHub provides the access to that. So for example, with GitHub, you can allow a certain set of people to view your project if it's private, or disallow. You can allow certain people to make commits. You can only allow yourself to make commits. That prevents just anybody from going down and trying to be a jerk, basically, for lack of a better word. I just wanted to check my notes. What else do I have for GitHub? GitHub has various free and paid plans available. I don't remember what their current pricing model is. I guess we could click on it somewhere and look it up. Pricing, there it is. They have various plans. I think the free plan is what most people use. Yeah, $0 per month versus $7 per month. They have a bunch of different plans. You can click through those if you want to use GitHub. I'm not going to go too much into that, but most people use the free version of GitHub for most everyday people's needs. I think they might have actually expanded it in the last couple of years. Before they had like a limit, didn't they, on either repositories or the people who could access the repositories and the people we could share it with. I can't remember what it was, but anyway.
Well, so you could only have open source repos free, and recently Microsoft allowed private repos for free. So then you can have private repos on there without paying any additional.
I got you. Thank you. Yeah, that's what it was. Yeah. And Microsoft actually recently bought GitHub. I think it was last year, just last year.
Yep.
Yeah. That's kind of, I think, all that I have left actually for my presentation. I guess let me know if you get any questions through the stream.
Trevor says the private repo has a very small contributor limit on the free account.
Makes sense, yeah.
So you can only have like maybe a couple of contributors to your project, it sounds like. But Trevor actually did ask a question about, let's see, what did he say? Scroll to this question. Can anyone suggest a document format, i.e. natural language, not source code, that plays nicely with Git? So I sent him a URL that might answer his question, because he wanted the output to be like in a PDF format, the diff at least. So I think that might answer his question. But I think also more importantly, Git will do a compare on a line-by-line basis. So if your paragraph just is one long line that a text editor will word wrap for you, Git will interpret that as just one line. And so that's something else to keep in mind if you are, if you got a file with long paragraphs that don't have a space break or line break in it, Git will treat it as one line. So
yeah, and you could actually see an example of that in my first few minutes of the presentation. I think my initial little bio was all one long line, and so the first commit I made was to break it up into multiple lines by adding new lines.
Right, exactly. Yeah.
Just so we can see it and work with it better. Yeah, Git will work with any kind of file as far as I know, but it works best with text files. That's a good question.
Yeah. Large blob files like that don't work too well in Git, because then if you've got one long line, it doesn't work great. Trevor says, expanding my question, what OOO/LO supports to? I don't know what that means.
OOO, object-oriented, I don't know.
Let me paste this question in our Hangouts chat. Open office org.
Oh, so your mileage may vary with that one. So binary formats, I've tried it with Word doc files, docx, doc. I don't remember if I tried it with Open Office document or LibreOffice full files, but it should be fairly similar. Those will work up to a point, but the problem with those is that they have kind of a binary format. You can see a lot of your text inline if you do like a git diff. You can see a lot of it being changed there, but it has a bunch of binary symbols in there as well. So it sometimes will work, sometimes will not. A lot of times will not, unfortunately.
Yeah, they have metadata. And he says he's not trying to add, he's not trying to go to their native format. So if you're looking for, I don't know, you might just want to go with like Google Docs or something else similar, because they do a pretty good job of doing a word-by-word comparison if you're dealing with large text. That's not source code.
Yeah, if you're talking about formatted text especially, yeah, because all the special binary tags and symbols to
Google is too evil, he says. So run OwnCloud, or what's it called now? Cloud? No. Yeah, OwnCloud.
OwnCloud.
I think that's what it's called. Run your own cloud. Yeah, OwnCloud. He says he has his own GitLab server now.
Oh, cool.
Yeah, GitLab's great. I love GitLab.
Yeah, GitLab's cool.
All right, I think that was the only question. Hopefully that article solved your problem, Trevor. At least one of them. All right, cool. Any questions from anybody else? So I don't know if Kevin fixed the Discord link for the Tri-City Game Dev or not.
I did, yeah. I linked it up above, but I can link it again.
There it is. All right. Oops. In case you're wondering, that is the new link for the TC Game Dev Discord. Him and I were playing around with the full stack Discord server as well while Casey was presenting. So we may have that for the next meetup, but we'll see. We're gonna pilot it and see how it goes. So, all right. Anything else you want to plug, Casey, before we sign off?
Not really. I mean, I plug for Git, I guess. I love using Git, so thank you for watching the presentation, and you have a great evening.
Yeah, thanks so much, man. Well, for everybody else that's online, hopefully we'll see you guys next month. April 3rd is the first Wednesday, and Saban will be out here from Seattle to give a presentation on API and testing using Node.js. So hopefully we'll see you out there, and hopefully there's no more snow. Will there be more virtual talks? So we live stream every single talk on Twitch. And so that even if the plan is we will continue to meet in person, but we will also continue live streaming it. And we might change it around to where we can maybe have people give feedback with audio and everything, maybe through Discord or something like Zoom in the future. So we'll see. That'd be kind of cool for people who want to join remotely to actually be able to ask questions without just having to type. Cool. All right. Will you throw your notes up on GitHub and I'll send them out to people.
Yeah, cool. I'll probably won't get to them tonight, but look for them in the next couple of days for sure.
All right. Excellent. Thanks, Casey. And thanks for joining.
Yeah. Thanks, Michael. Thanks, Kevin.
Have a good night.
Yeah, you too.